Graphing a rational function is a rather lengthy process because of many properties that function has. There are 7 steps that will follow to end up with the graph of the function. The steps are listed on the left, and on the right we'll work on the example. Function f of x is x squared plus x minus 12 over x squared minus 4. We'll start with the domain of the function. Since it is a rational function, to find the domain we need to solve the equation denominator equals 0 and exclude the zeros of the denominator. So we'll have x squared is equal 4 and therefore x is equal plus or minus 2. And therefore domain of that function is the set of all x's such that x is not negative 2, no 2. The second step is to find the intercepts. We'll find the y-intercept. By definition, y-intercept is the value of the function at 0. And if you substitute x with 0 in the formula, we'll have negative 12 over negative 4, which is 3. So the y-intercept is the point 0, 3. As for x-intercepts, we need to solve the equation f of x equals 0. So in this case, it's going to be equation x squared plus x minus 12 over x squared minus 4 equals 0. Because it's a fraction, to solve this equation, we multiply both sides by the denominator. So the next will end up with just numerator equal 0. That's why in the definition of the intercepts of the rational function, we just say that we need to solve the equation p of x is equal 0. This is a quadratic equation, and therefore we can solve, for example, by factoring. This polynomial factors as x plus 4 times x minus 3. So equation will give me the zeros negative 4 and 3. So the points 4, negative 4 and 0 and 3 and 0 are x-intercepts. Step 3 is to find vertical asymptotes. So to find vertical asymptotes, we have to check first where the function is in the lowest terms. So let me factor the numerator and the denominator. We already know that numerator factors as x plus 4 times x minus 3, and the denominator factors as a difference of squares as x minus 2 times x plus 2. You can see that there is no common factors, and therefore our function is already in the lowest terms. And therefore, to find the vertical asymptotes, we'll take the denominator. We can take it in a factored form and solve it. Make it equal 0 and solve for x. We'll get x equals 2 and x equals negative 2. Those solutions become at the same time the equations for the vertical asymptotes. Step 4 is to find the horizontal oblique asymptote. So we are looking for relationship between the degrees of numerator and the denominator. Because the degree of numerator is the same as degree of the denominator, there is a horizontal asymptote, and that horizontal asymptote will have the equation y equals leading coefficient of the numerator over leading coefficient in the denominator, that is 1. So y equals 1, horizontal line is horizontal asymptote. And step 5 is to check whether the function, graph of the function, crosses the horizontal asymptote. For this, we need to solve the equation f of x equals equation of the horizontal asymptote, which is 1. This leads us to the equation x squared plus x minus 12 over x squared minus 4 equals 1. We multiply both sides of that equation by x squared minus 4 and we'll get x squared plus x minus 12 equals x squared minus 4. If we bring x's to one side, the x squared will cancel out, and what will be left is x equals 8. So the graph intersects the horizontal asymptote when x is equal 8, because y on the horizontal asymptote is 1, the intersection point is 8, 1. The next step is to check for symmetries. We'll use the definition of even and odd function to determine whether the graph is symmetric with respect to x-axis or origin. So let's check where the function is even. Let's compute f of negative x. If you substitute x for negative x for x in the formula, we'll have x squared minus x minus 12 in the numerator over x squared minus 4. And if we compare those two formulas, you can see that they are different, and therefore function is not even, and there is no symmetry with respect to y-axis. Maybe function is odd. Let's check whether condition is satisfied. So for this we need to know what is negative f of x. That's going to be negative x squared plus x minus 12 over x squared minus 4. If I bring negative into the numerator, I will have negative x squared plus minus x plus 12 over x squared minus 4. And if I compare f of negative x with this formula for negative f of x, I see that they are not the same, and therefore the function is not odd, and there is no symmetry with respect to origin. So there is no symmetry for the graph of our function. The step 7 is to determine on what intervals function is positive and on what it is negative, which tells us whether the graph of the function is above x-axis or below x-axis. So we are making the sign chart for function f of x. We'll plot on the number line, we'll plot the points excluded from the domain. So this is negative 2 and 2. These points will never be included in our consideration, and we'll put also the intercepts, negative 4 and 3. Those points divide number line into 5 subintervals, and will determine the sign of the function on each subinterval by computing value of the function at the test point. So the intervals are from left to right, from minus infinity to negative 4, from negative 4 to negative 2, from negative 2 to 2, from 2 to 3, and from 3 to plus infinity. In each interval we choose a test point. So for example, in the first one we can choose negative 5, then negative 3, then 0, then 2.5 and 4. Now we compute the value of the function at each of those points. So if x is equal to negative 5, the value of the function is 8 over 21. The value is positive, so the sign is plus. We can put it above the number line, the plus sign, but if the function is positive on that interval, it means that the graph is going to be above x-axis. When x is negative 3, the value of the function is going to be negative 6/5, and therefore value is negative. This can be illustrated by putting minus sign above that interval on our number line. And if value is negative, it means that the function is, or the graph of the function is below x-axis. For 0, the value is 3, the value is positive, so we'll put the plus sign on the above the number line, and that means that the graph of the function is above x-axis on this interval. For 2.5, the value is negative 13/9, the value is negative, and therefore the graph is below x-axis. And for 4, the value is going to be 2/3. The value is positive, so the graph is above x-axis on the interval from 3 to plus infinity. And finally, we are able to graph the function. So in the coordinate system, we draw all the asymptotes, x equal -2, x equals to y equal 1. We plot the x-intercepts, we plot the y-intercept. Point 81 was the point where graph crosses the horizontal asymptote. We can plot additional points that we obtain in a step 7. So this was -5 and 8/21. So somewhere here would be that point. Then we had point -3 and -6/5. So somewhere here it's going to be that point. For 0, it's 3. We already have this point. For 2.5, we'll have -13/9, and for 4, we have 2/3. And we can graph that function now. On the interval from -infinity to 4, the graph is above the x-axis. It cannot cross the horizontal asymptote because 8.81 is the only point where the graph crosses the asymptote. So the only way the graph can go is from below the asymptote through the points that we have to the x-intercept. On the interval from -4 to -2, we know that the graph is below x-axis. The line x equals -2 is the vertical asymptote, so the graph has to approach this line, and therefore graph has to go the way to show that asymptotic behavior. Now, if you go to the interval from -2 to 2, we know that the graph stays above the x-axis. X equal -2 and x equal 2 are asymptotes. So to stay above the x-axis, graph has to approach asymptote from the above. We're going to the point 3 and we'll have to come back because the graph cannot cross the horizontal asymptote. There are no x-intercepts. It has to stay above the x-axis, so this is the only way that graph can go. Now, on the interval from 2 to 3, the graph is below x-axis, and we know that x equal to is asymptote, so the only way it can happen is if the graph goes down. Then on the interval from 3 to +infinity, the graph stays above the x-axis, goes through the point 4 and 2/3. We know that it goes also through the point 8,1 because this is the intersection point. So that means that this graph will continue past that asymptote, but then remember that y equal 1 is the horizontal asymptote, so somewhere there the graph will have to turn around and toward the asymptote y equals 1. And this is the graph of that rational function.